This video is all about inspecting and diagnosing a variety of issues on a Porsche 944. Whether you're a new 944 owner, a potential buyer, or simply working through some issues on your car, you should stick around as we get into everything from visual inspection of common problems to some mechanical and electrical diagnostics as well. So let's get started. Today we have a 1986 Porsche 944 Turbo in Guards Red. This car came down from Virginia for some service work and actually has a pretty interesting backstory. So when the owner was a child, his father had a red 944 Turbo that he absolutely loved. And in around 2008, when he was about 7 years old, his dad decided to sell the car. And of course, he was absolutely devastated, as any 7-year-old would be. But some years have passed, and as an adult now, is embarking on a 944 journey of his own. And he ended up finding a 944 Turbo for sale out of Maryland. So he drove up to see it. And by sheer coincidence, it happened to be his dad's exact car, believe it or not. And the new owner even had the original Craigslist ad from when his dad posted it for sale, 15 years earlier, which was amazing to see. And of course, he had to buy it. Sentimental value, get the car back in the family. So very, very cool. And he's super stoked to have this car. And he's excited to get working on it and shine it up a bit. And he paid about $8,000 for the car. And for a running, driving turbo, it's in pretty clean condition. I think it's a great price. And so what we'll do, we'll take you around the car and kind of give you a quick look at its overall condition inside and out, and then we'll get under the hood and talk about some of the service items we'll be looking at today. Over on this side, we do have a little bump here that could be touched up, but this side panel is very straight and damage-free for the most part, nice and clean. Got some beginnings of a split here on the upper door panel, which is very common to see on these cars. What happens is the window guide inside the door pops its weld up top, and then it starts to push and apply force on the outer door panel, and it eventually cracks. So probably go in there and make sure that that is re-welded and in good shape. Moving around the back, we can see that there is a little bump here that someone has tried to pop out and touched it up with some paint, but it's not rusty or anything like that. You'll notice some rubber plugs on the rear body panel here, and this is from where a Heckblende was installed, which is German for rear panel. It was a reflective panel that was a dealer-installed option at the time that would bridge the gap in between the two taillights, and it came in a variety of different scripts like Porsche, 944, or Turbo. And when that was installed, the license plate would be relocated to the lower bumper here, and so it does require drilling out a couple holes to install that panel, and someone has clearly removed it and put the license plate back in its original position. So you just want to make sure if you're plugging these that the metal's not exposed, you can seal it up. You don't want any rust or corrosion setting in there. The Porsche decal appears to be original, a few cracks in some areas, but otherwise in pretty good shape. The side panels are in pretty good shape as well. I did notice that in the area of the stone guards, right down this top section here, there's a darker shade of red and a lighter shade of red above it. So someone has removed the stone guards and replaced them, just kind of where the original paint color was protected, but the stone guards otherwise look brand new. These quarter window seals have also been replaced. They're nice and smooth and crack-free, soft rubber. The window slot seals on the side are a little bit weathered, so you could replace those for about $60 a piece, one on each side. The roof panel is just a little bit faded. We can see kind of some white swirl marks where maybe there was some wax that wasn't fully removed or maybe got baked on, but this could be buffed back and is otherwise in pretty good shape too. I'm not seeing any signs of a respray on most of these body panels. There's not, any strange tape lines or, overspray on anything. A lot of times these bolts back here will get sprayed and they're still original. So appears to be all the original paint on the car with the exception of the nose panel. You can see this nose panel is a slightly different shade of red, and these panels are smooth, not much orange peel going on with these, a few micro fractures and things, but this panel's got quite a bit of orange peel, so very clear that someone has repainted this, possibly due to rock chips. As I'm looking at these panels, the headlight covers, the fenders, and the hood all match and tie in together. It's just this nose panel, so this could be stripped down and refinished. I would probably do, a good wash on the car, some clay bar to remove any contaminants, and take a DA buffer with some polishing compound and just kind of bring everything back to the original shine, which this Guards Red single stage is pretty good from a restorative perspective. And then once that is good, have this stripped and resprayed to color match, and that'll make a big difference with everything kind of lining back up here in the front. Porsche crest is in great shape as well. You could pop on a new seal under there, but definitely reusable in that respect. I did notice the windshield wipers are positioned a little low and they're catching under the windshield glass and under the hood, and this one's hitting here. So these can easily just be removed. Pop the nuts on these and tilt them up kind of one spline on the mounting shafts there and get those out of that lower position, and operation should be a little bit better with that. Pretty easy to do. The car's got some staggered 16-inch phone dial wheels with relatively fresh tires, so 2023 date codes on the front and 2021 date codes on the rear, so definitely some life left in those, and they look pretty clean. Taking a look inside the cargo area, the carpeting still has most of its original fibers, some pretty good shape, and someone has replaced this hatch seal. It's pretty soft and it's not cracking. It is, however, pulling away from the corners a little bit on each side. So when you install these along the upper edge, you want to make sure that not only are you pushing it on, but you're kind of stretching it and pulling it tight along the top edge and down the side so that you have enough material to fully close the seal along the bottom here. So what I'd probably do is pull this seal up again and kind of reinstall it a little bit more tightly up top so you have more material down below, get a nice seal on that. The car currently doesn't have any rear hatch shocks installed. The owner was a little bit concerned about the rear glass delamination issue with these. In this case, the upper seal is actually looking really clean. I don't see any issues there, which is good. Also checked out the build tag sticker inside the cargo area here. Pretty standard equipment on that. The car, as we get inside, we'll see it does have sport seats, but I did not see that on the options code list. No limited slip differential or anything like that, but as we get inside, we'll talk about the sport seats, and that's a great addition to the car. Cool to see. Taking a look inside the car, we can see that it's got a two-tone interior, black over tan, what Porsche calls linen, and it's probably one of my favorite interior color combinations on the 944. And of course, we've got some nicely bolstered sport seats in here. They do have some cracks in the material, some tears, so these can be recovered. Only944.com has got some good quality leather material that you can purchase and recover these for about $500. So that's something to look at. We've got some Lloyd mats with the turbo script down here. A few cracks in the dash, pretty common on these. Could look at a cover or a dash cap for that. Difficult to source these later dashes. You could get a used one, but not always perfect in that sense. But otherwise, really clean in here. You could just shine up a few items. The rear seats could be replaced on the upper bolsters as well. Missing some seatbelt connections in the back, and it does have a Bluetooth CD head unit installed. Shift boot looks nice, leather looks clean there, steering wheel's in pretty good shape, and we've got 125,000 miles on the odometer. So a few things you could do in here just to shine things up a bit, but otherwise really good condition all around. Also notice we got a little bit of play in the shift lever here, which is pretty standard on these. The play a lot of times comes from the linkage in the back. There's some rubber bushings that wear out, and there's also a pin on the shift lever that can develop some wear on the outer edge, kind of get barreled with this linkage, and so first is way over here. So either one of those or possibly both of those things could be happening. We'll pop this up and take a look and see if we notice anything, and possibly recommend a shift lever replacement or shift linkage in the back. Take a look at that. Taking a look under the hood, we'll notice a few things here. So we've got some adjustable sport suspension installed up front, pretty cool. And these fuel lines have been replaced with some braided lines. They appear to be in nice condition. Always good to care for those rubber lines. You don't want any fuel leaks or potential fires back there. The motor looks to be missing from the windshield washer system, some tubing gone as well, and a cracked boot on the headlight motor relay. Over here we have a K&N cone style filter installed on the intake, and looks like it could be due for a good cleaning and re-oiling if you want to retain that. You'll also notice that the car is absent of coolant, and so that's one of the reasons that it is here today. The owner took it out for a short drive and ended up developing a coolant leak. Didn't notice it right away, and the car overheated. When he got home, he obviously addressed it and replaced one of the coolant lines, was refilling it and bleeding it a number of times, but he was concerned that because of the overheating, there was a potential head gasket issue. He did see some white smoke coming out the back on occasion. So that's something we're going to diagnose and take a look at today. After the owner replaced this upper line here and he had it running, there was, I guess, another coolant leak that developed, and it is leaking a bit more coolant. So we'll figure out where that's coming from. Probably get this refilled with some water and pressurize this, see what we got going on for leaks, and we'll end up dumping the entire system and refilling it with coolant anyway. You also recently noticed a low idle, kind of rough idle, so we'll take a look and see if there's any obvious vacuum leaks. It could be a number of issues, idle control valve, clogged fuel filter, and injectors, spark plugs can kind of run the spectrum there, but vacuum leaks pretty common on these, so we'll do a quick scan around and see what we can find and do some diagnostics if we need to. So we'll get that filled up, start it up, and take a look at that idle real quick and see if we notice anything with a quick once over. And after that, we'll pull the spark plugs and do a compression test on each of the cylinders and see if we can see any variation there that would indicate possible damage to the head or the head gasket, and kind of go from there. As you can probably see, the idle was struggling quite a bit there, and so I've checked around everything that I can get to from the top of the engine. There are a number of different vacuum lines and intake hoses that run around the engine bay here. Everything seems pretty tightly connected and correctly plugged up top. However, I did notice down here at the J-boot, after the AFM, this clamp is a little loose, and I can move this boot. So this probably just wasn't clamped down all the way the last time somebody was in here. Not a big deal, but I'm guessing this is what the issue is, so we'll tighten that down and see if there's any improvement. Well, we really didn't see any improvement there, so we'll have to diagnose that idle issue a bit further. We'll go ahead and run a smoke test through the intake and ensure that there are no other vacuum leaks or anything strange going on in a bit, but for the time being, I'm going to go ahead and remove this cone filter and the airflow meter so I can get a better view of the coolant lines down here. We'll pressurize the system and see if we can replicate that leak and find out where it's coming from. This pressure tester connects directly to the coolant expansion tank in place of the fill cap, and it screws right on just like the cap would. We'll get it connected up and tightened down and pump it up to about 15 psi. The overflow cap is rated to vent coolant at 1 bar, which is about 14.5 psi. So 15 is enough to get some pressure in there to replicate the leak without damaging anything. So we'll get it pumped up and see what we can see. Well, there it is. Well, we made it to 7 psi, and we've got a fountain shooting from the water pump, coolant line that runs from the radiator to the pump, and so that's why it was collecting over here. We'll definitely need to replace that. Not seeing any other coolant leaks at the moment, but we'll definitely get that radiator hose added to the parts list for this car. Next up is the compression test, so we'll get the spark plug cables disconnected and remove the spark plugs. We'll also go ahead and remove the fuel pump DME relay so we can turn the engine over without it firing, and we'll connect the gauge up individually to each cylinder, crank the engine over about 6 to 8 times with wide open throttle so there's enough air coming in, and we'll see what results we get on this cylinder head. The The compression test results came back on cylinders 1, 2, and 4 right around 120 psi, which is about where I'd expect a turbo car to be on the lower end of the scale, so not a big deal there. However, cylinder 3 tested at 67 psi, which is pretty low. I went ahead and ran a second dry test and followed that up with a third wet test by adding some oil, and was able to get it up to 70 psi on cylinder 3. For a healthy engine, we're looking for values across all the cylinders to fall within about 10% of each other or better. The good news is the piston rings are probably fine in this case, but definitely a head gasket or a valve issue on cylinder 3. So with that out of the way, let's move around the engine a bit more and see what else we can diagnose before we start tearing it down. Since we're here, let's go ahead and take a look at some of these ignition system components as well. When the spark plugs were removed, I did notice a bit of carbon fouling on the ends, which usually indicates the engine was running rich, but it could also be a weak spark partial ignition issue. So we'll take a look and see if we see any rips, tears, fraying, or damage in any of the leads here. And as I'm looking at the material, it is all pretty flexible and soft, looks to be in pretty good shape. I am noticing a split on the last lead for cylinder number 4, but it's not completely torn through, so that may be reusable. Based upon the markings, these are Bosch spark plug cables with Baru plug ends, which would be OEM equipment. The digital motronics on these engines were paired with resistorized spark plug leads, so each one is rated at 3,000 ohms. If you go down the line and do a resistance check, they should all come back at 3,000, and in doing so on these leads, I found the first one to be right at 3,000, while the remaining ones came in about 2,800 to 2,900, so pretty close to within specification, probably a little bit more life in the spark plug leads if we want to keep those. The next thing we want to check out down here is the distributor cap and ignition rotor, and from a visual inspection standpoint, you can go ahead and give it a little wiggle, make sure that it's firmly seated and locked in place, otherwise you could have some contact issues inside. We can go ahead and remove the distributor cap by turning the spring-loaded locking screws 90 degrees clockwise. And once you're inside, you want to take a look at the rotor. Make sure the plastic isn't damaged or broken and that the metal contact blade is clean and relatively smooth. Any signs of pitting here would warrant replacement. Inside the distributor cap, we also want to inspect each of the 4 contact points. There shouldn't be any deep grooves or significant pitting here either. And in this case, the ignition rotor is a little fouled on the end, and the cap contacts actually have some really deep pitting. So these are 2 items that we'd want to replace to improve the car's overall ignition response. As for some electrical items, we can check out the DME temperature sensor and the throttle position switch. The DME temperature sensor provides a resistance signal to the DME computer so they can adjust the fuel mix for various engine temperatures. The sensor is located in the engine block below the front of the intake manifold, and after removing the connector, we're looking for a reading between 3,300 ohms at 59 degrees Fahrenheit and 1,400 ohms at 86 degrees Fahrenheit. Today at 65 degrees, it's reading 2,700 ohms, which is within specification. If this was a low reading outside the range, the engine would run lean and a higher reading would run rich. We can also ensure the DME is receiving the signal by testing for the same resistance on the DME connector at terminal 13 and a ground connection. The throttle position switch is located on the throttle body, where it sends signals to the DME computer for throttle positions between idle and wide open throttle. When the TPS is correctly adjusted, you should hear a clicking sound right as the throttle is opened. Here we'll first test the idle contact switch with the TPS closed by checking for resistance of 0 to 10 ohms between terminals 4 and 6 on the TPS connector. Next, with the TPS open, that resistance should change to infinite ohms. In this case, I'm not getting a reading and the switch isn't clicking, so we'll adjust that in a moment. Next, we'll test the throttle potentiometer by checking resistance across terminals 2 and 3 on the connector. With the throttle closed, the ohm meter should read between 320 and 670 ohms. With the throttle fully open, the ohm meter should read between 2,700 and 4,700 ohms. This reading should also increase at a linear rate from the full closed position to the wide open throttle position. Let's go ahead and adjust the TPS by loosening the 2 mounting screws. From here, the switch can be turned to a point where it actuates just as the throttle opens from a closed position. We can now hear the switch clicking, and I'm getting a resistance reading that's a little above specification, but at least we now have continuity, so we'll see how that affects the idle condition. Again, at the DME wiring harness connector, we can also test the idle contact with the TPS closed by checking for the 0 to 10 ohms between terminal 2 and a ground connection. Next, with the TPS open, that resistance should change to infinite ohms. The throttle potentiometer can also be tested at the KLR unit plug by checking for resistance across terminals 22 and 23. I've got all the ignition components and vacuum lines back in place now, and the next thing we'll do is a smoke test on the intake system to check for leaks. With the smoke machine set up, we can install the adapter cone on the J-boot and tighten down the ring clamp so it's a good seal. Next, we'll connect the smoke nozzle to the adapter and wedge the throttle open so the smoke can freely move through the intake. And now we're ready to run the test. I went ahead and let the machine run for a few minutes while scanning around the engine, and I didn't see any leaks here, which is great. Just so you can get an idea of what a vacuum leak might look like, I've loosened up one of the smaller lines at the fuel pressure damper, and you can now see how smoke worked its way out of the system. But since this system looks all sealed up, I'm going to go ahead and reinstall the AFM and start the car again and see if the throttle position switch adjustment provides any improvement to the idle condition. Well, that's certainly a lot better than before, which is great to see. The idle settles right in at around 950 RPM at cold start, and it's not hanging around 600 like it was before. You may have noticed while the car was running that the voltage reading on the dash looked a little bit low, so I went ahead and performed a simple voltage test on the battery to gauge the alternator's output while the engine was running. A healthy 944 alternator should fall between 13.8 and 14.5 volts, and this one came back at 13.9, which is within spec. If the alternator output was below 13.8 volts, that would indicate a problem with the alternator itself, the voltage regulator, or the charging system wiring. While I was here, I also noticed that the negative lead on the battery was loose, so we'll get that tightened down as well. As for other visual inspection items, knowing the condition and color of the fluids in the engine can help to identify the source of various fluid leaks. When checking the engine oil, we can see that the fluid level is topped up, and it's currently a medium brown color. The fluid level and the power steering reservoir looks good as well, and it's really clean actually. This calls for Dexron 3 ATF, which is a bright red color, so that should help us differentiate between the two fluids, especially on the right side of the engine where they tend to converge. As we get into the car, we can see a fair amount of brown fluid collecting on the power steering pump. This can initially present as a power steering leak, but there's a few things I'm seeing here. So when the pump leaks, it tends to seep fluid from the front shaft seal as well as the seam between the two halves, and the front of the housing here is pretty clean and dry. The sway bar bushing that sits behind the pump will also tend to become swollen from exposure to the automatic transmission fluid from a pump leak, and this one seems to be in good condition. We can see the same color fluid collecting on this oil hose and dripping down on the pump, which appears to be the source of the leak. In addition to the oil cooler on the engine block, the turbo cars feature an external oil cooler tucked inside the lower front bumper here, and that's where this hose is leading. I don't see any obvious damage to the line, so I'm hoping we can just tighten up the connection on the oil cooler housing. Moving on a bit further, we can see some bright red fluid collecting on the inner left side of the steering rack, so it's pretty clear this is a power steering system leak. The steering rack tube is joined to the housing with a threaded ring at this location, and when rebuilding the rack, the ring has to be tapped loose with a hammer and a punch. And we can see some tool marks at the base where someone has probably rebuilt this rack in the past. Inside this connection point is a seal and a bushing, and I don't know if that was installed incorrectly or if the rack has just aged out again, but this is something that can be corrected down the line, either with a replacement steering rack or another rebuild on the existing one. Well, that completes our diagnostic test for the time being. We ended up ruling out a number of suspects while correcting some other issues along the way, which is great. We're going to start breaking down the engine for a head gasket replacement, and while we're in there, we'll replace the timing and balance shaft belts, have the injectors cleaned, and address anything else we may find. I want to give a big thank you to the owner for bringing this car in and sharing it here with us. Hope you enjoyed checking it out and diagnosing it as much as I did. But anyway, that's all for today. Thanks for watching.